Hey everyone, welcome back. Ready for another deep dive. Today we're going deep into the world of transportation modeling.
Yeah, we're going to unpack some pretty fascinating research.
It could actually change how we think about traffic and tolls,
Mm-hmm.
maybe even city design.
All right, so to get us started, what are we looking at today?
Basically, how engineers can predict how traffic's going to flow
Okay.
when drivers have different values of time.
Okay, so like time is money kind of thing.
Exactly. And when some roads have tolls.
Gotcha. Now, where's all this coming from? Some super secret lab?
Not quite. It's an academic paper.
Okay.
It is pretty heavy on the math side, I'll be honest.
Oh boy.
But don't worry, we're going to break it all down.
Okay, good.
Make it understandable and honestly pretty fascinating.
I hope so. Give us the hook then. What's the big takeaway here?
So get this. There's a way to model traffic flow
Uh-huh.
without having to track every single driver's choices.
Wait, hold on. How is that even possible?
It's all about a clever way of ordering things. Ordering things? Okay, now you really got to explain this.
Think about it. Some people, they're willing to pay extra
Right.
to save a few minutes on their commute.
Yeah, I can relate to that. Big meeting, got to be on time.
Exactly. Time is money for those folks.
For sure.
Then you have others who are way more budget conscious.
Right.
They'll take the longer route to avoid a toll.
Yeah, makes sense.
Did
Different
we-
drivers, different priorities.
Right. And traditionally, this whole thing's been modeled
Okay.
using something called multi-class by-criteria traffic assignment.
Multi-class what now?
Multi-class by-criteria traffic assignment. We'll just call it MBTA.
MBTA.
Got it.
So what's the problem with this MBTA?
Well, imagine you're trying to track every single driver in a big city.
Like Chicago, for example.
Yeah, like Chicago, but across all the different types of drivers.
Oh, okay. So not just every car, but like every kind of driver.
Exactly. It gets complicated fast.
I bet. My computer would probably crash trying to run that model.
You're not wrong. The classic MBTA, it needs a ton of memory.
Because...
It creates separate variables
Uh-huh.
for every type of driver
Okay.
on every single road segment.
Whoa. So it's like a massive spreadsheet with like a zillion cells.
Pretty much. The researchers actually looked into this,
Right.
adding just a few more types of drivers.
Yeah.
The model needs gigabytes of memory.
Gigabytes. That's insane.
It's like trying to run a modern video game on like a really old computer.
Oof. Yeah, that's not going to end well. So this new research, it's offering a better way.
That's where things get really cool. It simplifies everything.
Okay, but does it still work?
Oh, it's still accurate. They do it by focusing on, like, the order of things.
Order. I'm intrigued. Tell me more.
Instead of tracking each driver's decision,
Yeah.
they sort everything beforehand. The routes, the drivers, everything.
Sorted how? By like speed limit or what?
Think about lining up all the possible routes,
Okay.
from the cheapest toll to the most expensive.
Oh, interesting. Okay, and then...
Then you line up all the drivers, from those who care least about time to those who care the most.
So it's like a matchmaking system for drivers and routes.
Exactly. They actually use this term in the paper.
Okay.
Time equivalence of money. TEM.
TEM. Got it. So like a low TEM driver is chill with taking the slow route?
Yep. High TEM, they'll pay to get there faster.
Ah, okay. So by sorting everyone like this...
You can predict who goes where.
Wow, that's so smart. It's like solving a puzzle by looking for the pattern,
Yeah.
not just trying every piece.
You got it. And here's the kicker. This simpler method, it gets the same results as the old one.
No way.
Yeah.
So it's both simpler and just as accurate.
Yep. The math proves it. They even call it Theorem 1 in the paper.
Okay, well, I'm not going to check the math, but I'll take your word for it. This is impressive stuff.
It's not just about saving memory either. This new approach, it's also faster.
Faster. Okay, now I definitely got to hear more about that. So we've got this new model. It's accurate. It's way more efficient.
Mm-hmm.
But what's in it for us regular folks? Stuck in traffic, you know?
Right, right. It all comes down to real-world impact.
So are we talking flying cars,
Yeah.
teleportation?
Not quite.
Okay, good. But how could this actually help? Like a faster commute?
Well, one of the big things is
Yeah.
it helps city planners
Uh-huh.
and traffic engineers
Okay.
to do a much better job predicting traffic flow.
So it's like a crystal ball for traffic.
Kind of. Imagine being able to simulate
Uh-huh.
the impact of adding a new lane to a highway.
Oh, okay. Or like changing toll prices.
Exactly. And you can do all that before you even start building.
That's amazing. No more guessing games.
No more guessing games. It's a virtual testing ground for solutions.
So we're talking smarter traffic lights,
Potentially.
apps that actually help us avoid traffic jams.
Absolutely. It could lead to a smoother, faster commute.
Wow, I'm liking where this is going.
Think about emergency response times, too.
Oh, yeah. That's a good point.
If an ambulance can get through traffic faster
Yeah.
because of better planning.
That could literally save lives.
Exact.
Okay, so this isn't just like theoretical stuff.
Nope.
This is real-world practical stuff.
It has the potential to really change things.
Okay, now remember how we talked about getting info about specific driver types?
Yeah,
Even though the model doesn't track them individually,
right.
I'm still a little fuzzy on that.
Sure. So remember, it simplifies things by sorting
Uh-huh.
drivers and paths based on toll cost and time value.
Right, right.
Well, we can still figure out how many from each group
Okay.
are using a certain path.
Even though we're not tracking every single driver.
Exactly.
So it's like, I don't know, a zip file or something takes up less space.
Yeah, that's a great analogy.
But you can still unzip it and see everything inside.
Exactly. It's efficient and flexible.
Okay, cool.
They use this method called a transportation simplex tableau to get that detailed info back.
Okay. I won't pretend to understand all that, but the key is we're not losing info,
Nope.
even though the model is simpler.
We get the best of both worlds. Efficient and detailed.
All right, so we have an efficient model. We can still get all the details.
Yeah.
What else is there?
Well, this approach, they think it could apply to other stuff too.
Wait, really? Beyond just traffic?
Yeah, think about economics, healthcare, even social networks.
Well, hold on. You're saying this could be used for anything,
Oh,
where people have preferences?
pretty much. Anywhere people make choices.
Mind blown. So this isn't just a traffic thing. It's like,
A modeling breakthrough.
yeah, could change how we understand all sorts of stuff.
Exactly. Sometimes the best solutions
Yeah.
are the simplest ones.
And this one's all about finding order.
Yep, it all comes back to order.
It really is amazing, though, isn't it? How something as messy as traffic can be, understood so neatly.
It all comes down to finding the order in the chaos.
Right. So for our listeners who've been with us on this journey, what's the one thing they should remember about this whole new approach?
I think the biggest thing is even super complex systems like city traffic.
We can often understand them and predict them
Yeah.
way more efficiently than we thought if we find the underlying order.
Kids like finding the hidden pattern in a jigsaw puzzle, right?
Exactly. Suddenly all the pieces fit.
And here, that pattern is all about preferences and choices.
Right. And how those choices add up to the big picture.
So sometimes the most important insights, they're right there in front of us.
Absolutely. We just got to find the patterns that connect everything.
It's not about using tons of data, it's about being smart with it.
Right. It's like instead of hacking through a jungle,
Yeah,
you find a path that leads you straight to your destination.
I like that. So this research, it's not just about making better models.
No.
It's about making better cities,
Better transportation systems.
potentially even better lives for all of us.
It all starts with thinking differently, challenging the old ways.
Finding the connections that others might miss.
Exactly.
I think we've covered a lot of ground today.
Yeah, we have. From memory hogging models
To the elegance of sorting.
and how a simple idea can change everything.
Absolutely.
So to everyone listening, we hope this has sparked some ideas.
And maybe given you a new way of looking at things.
You never know. This sorting approach
Could inspire some amazing innovations.
in all sorts of fields.
The possibilities are definitely out there.
We'd love to hear your thoughts on this episode and any other deep dives you want us to tackle.
Keep exploring, keep asking questions.
Until next time, keep diving deep.
See you on the next Deep Dive.